So for the 2018 exam, free response question number 3, you're given the graph of G and it's made up of piecewise function from -5 to 3, and then a quadratic from 3 to 6, okay? And they tell you that this graph of G, the graph of the continuous function G, the derivative of the function f. So G is f prime. So G, I'm going to write right here, G is equal to f prime, okay? The function G is piecewise, and then from -5 to 3, and then it's the quadratic again from 3 to 6, okay? So question number A, or part A, if f of 1 equals 3, what is the value of f of -5? So let's go to our paper and let's do that. Because we're given f of 1 and we want to find f of -5, and we have the graph of f prime, okay, I'm going to want to integrate from -5 to 1. And that way I'm going from left to right. I'm going the correct order, okay? So I know if I graph or integrate from -5 to 1, f prime of x dx, I know that that's going to come out to be f of 1 minus f of -5, okay? And so if I move, because I have minus f of -5, if I move that over to the left-hand side and the integral to the right-hand side, and f prime of x becomes g, right? Okay, so then I would have f of -5 is equal to f of 1, and then because I'm moving it over, it's going to become minus the integral from -5 to 1. And instead of f prime, I'm going to write g, okay, because they're the same thing. Okay, because f prime of x is equal to g of x. Okay, all right, so I know this one is 3, so that's going to be the start. Okay, so f of -5 is equal to 3 minus, okay, and then I'm going to use areas to figure out the integral from -5 to 1. Okay, so from -5 to 1, okay, I'm going to break this up. One way is you could see this as a trapezoid, okay, or you could see it as a rectangle and a triangle. You could do it that way too. I'm going to do it as a rectangle and a triangle. So I know, because the scaling's by ones, that this is going to be 3 by 3, right? Okay, so 3 by 3. So minus 3 times 3, okay, and then plus, and you know what? That's below, so I need to do a negative here, okay? So -3 times 3, and then minus 1/2, and then that's 1 times 3, or 3 times 1, okay? And then to 1, then I need to do this one, right? So 1/2, 1 times 2. So plus 1/2, 1 times 2. Okay, so why are these two negative, these two areas? It's because it's below the x-axis and we're going left to right. Okay, and why is this one positive? Because that one's above the x-axis and we're going left to right, okay? All right, so this becomes 3, okay, and then minus, and this is -9, and this is minus 3/2, and then this would be plus 2/2, right? Or 1, you could write it 1, 2, all right? So this becomes 3, and I'm going to make this plus 9 plus 3/2 minus 1/2. And you have a numeric answer here. So if you stopped here on the AP exam, you'd be right, okay? Okay, you can clean this up a little bit more. So this would be, this should be 2/2. Sorry about that. That should be 2/2. Okay, so this should be 3 plus 9, which is 12. And then 12 plus 1/2. Okay, so that'd be 25/2. Because 12 is 24/2. Okay, all right. That's the question. That's the answer to part A, 25/2. F of -5 is 25/2, or 12.5. Okay, you could write 12.5 too. So for part B, we want to evaluate the integral from 1 to 6 of g of x dx. And what we're going to have to do is we're going to have to break this up. We're going to have to break this up from from 1 to 3, because that's one function, and then from 3 to 6. So we're going to have to break this one up, okay? So we'll go to our paper and we'll do that. All right, so to find the integral from 1 to 6 of g of x dx, what we're going to need to do is we're going to break it up from 1 to 3 and then 3 to 6 because they're different functions, okay? So this is equivalent to the integral from 1 to 3 of g of x dx, and then plus the integral from 3 to 6 of g of x dx. Now from 1 to 3, that's just a square right here, right? So that's just 2 by 2. So we can get the area, the integral here by just finding the area of the square, which is 2 times 2, or if you wrote 4 there, that'd be fine, okay? And then plus, and then we want to do the integral from 3 to 6, right? So the integral from 3 to 6 is this function 2 times x minus 4 squared dx, okay? So a couple things, I'm going to pull my 2 out. I'm going to let u equal x minus 4, and then du would be, because I have a inside function inside this squaring function, okay? So you want to use integration by substitution. So du would equal dx, okay? And so this would be 4, and then plus, and then I'm going to bring the 2 out, and this is going to be u squared, and the dx just becomes your du, so it's u squared du. Okay, and we want to evaluate this from 3 to 6 for x's, but we just changed it to u's, so we need to switch these to u's. So if x is 3, then u would have to be -1, and when x is 6, u would have to be 2. Okay, so this is equal to 4 plus 2 u cubed over 3 evaluated from -1 to 2, right? And it's only this piece that we're evaluating, okay? Because that's where the integrals, actually I should do this to make it clear. Okay, so this is 4 plus, and this would be 2 times 2 cubed over 3 minus 2 times -1 cubed over 3, close my bracket, okay? All right, so then this becomes 4 plus, and this would be 8 times 2, which is 16, so 16 thirds, and then minus, I really don't need the brackets now, okay? Minus, right, this is going to be -1 times 2, right? So -2, but I'm subtracting, so it's actually, this is going to now become plus 2 thirds. 16 and 16 thirds plus 2 thirds is 18 thirds, which is 6. So this is 4 plus 6, which is 10. So my integral here is 10. Okay, and that's part B. So let's go on and let's do part C. So they're asking you on the open interval -5 to 6, on what open intervals is the graph of f both increasing and concave up, and then we need to give a reason for this, okay? So f is so let's figure out the increasing first. So f is increasing where f prime is positive. Well, we're given the graph of g, which is f prime. So f prime would be positive wherever this graph is above the x-axis. So wherever this graph is above the x-axis, for those x values, okay, f would have to be increasing, okay? Now, how about the concavity of it, okay? So concave up, that means the second derivative would have to be positive, okay? What on this graph is showing me f double prime is positive, okay? Well, we're given the graph of f prime, so one derivative away from that, right? That would determine where this is increasing, would determine where f double prime, the next derivative of this, would be positive, okay? So if this function's increasing, that means the next derivative of this would have to be positive, which this next derivative of this would be f double prime, okay? So wherever this is increasing, which is right here, okay, it's increasing, which means the derivative of this, which is really the second derivative, would have to be positive, which would mean f is concave up on this interval. Now there's another place right here, and it's right here, okay, because there it's also increasing. So we're looking for where where f prime is above the x-axis and also where f prime is increasing. If it has those two things, where f prime is above the x-axis and f prime is increasing, these two things hold, okay? All right, so let's go to our paper and answer this. So we would say f is increasing and concave up on the open interval 0 to 1 and 4 to 6. Because f prime of x, which is equal to g of x, is greater than 0 and f prime of x is increasing on the intervals 0 to 1 and 4 to 6. So basically by saying greater than 0, f prime is greater than 0, okay, that's saying above the x-axis. And f prime is increasing, okay, so this is f prime is increasing means f double prime is positive, okay? So here f prime is positive and f double prime is positive because f prime is increasing, okay, on these two intervals. And that's why we can say f is increasing and concave up on those two intervals, okay? And that's all you have to say for part C, okay? Let's go on to part D. So for part D, it says find the x-coordinate of each point of inflection of the graph of f. Give a reason for your answer. Okay, so points of inflection are going to happen where f double prime changes signs. Well, we're given the graph of f prime, so we can tell the signs of f double prime by looking at f prime and see where it's changing from increasing to decreasing or decreasing to increasing, okay? And wherever that happens, that means f double prime would be changing signs, which would mean you have a point of inflection, okay? All right, so if you look, okay, where does this happen? Okay, so f prime is not increasing here, right? Or decreasing. Okay, now it's increasing, but then after that, it's not increasing or decreasing. Okay, after that, it's increasing, but after that, it's not increasing or decreasing, right? And then here, from 3 to 4, f prime is decreasing, and then from 4 on, f prime is increasing. So this is telling me the second derivative is negative, and right here, my second derivative is positive. So the second derivative changed from negative to positive. That's a point of inflection at x equals 4. And that's what we need to say, just what I just said out loud, okay? So we'll write it on our piece of paper. So we would just say f has a point of inflection at x equals 4 because f prime changed from decreasing to increasing at x equals 4. And that's enough justification, okay? That's the reason why, okay? All right, that's it for this 2018 question number 3. This was an interpreting graphs problem, okay? So the next problem we're gonna do, we'll do the next one, okay? All right, so that's it for question number 6 on the 2018 free response questions for BC. They're giving you the Maclaurin series for the natural log of 1 plus x, okay? And then they're telling you on its interval of convergence, this series converges to natural log of 1 plus x. And then let f be the function defined by f of x is equal to x times the natural log of 1 plus x over 3. So we're going to use this Maclaurin series for natural log of 1 plus x to figure out a series for f of x, okay? So this isn't f of x. This is the Maclaurin series for natural log of 1 plus x, okay? So some things you notice, okay? So this is being multiplied by x, that would mean I need to multiply each term of my series by x. And then in here, what's happening is I'm dividing my x by 3, right? So this is 1/3 x. So all of these x's here, I need to replace with x over 3. And that's basically it, right? X gets replaced with x over 3, and then I need to multiply the entire series by x, and that would be the series for f of x, okay? So let's go to part A, because it asks for write the first 4 non-zero terms and the general term of the Maclaurin series for f, okay? All right, and I think this is a perfect example of a question they could ask you on this year's BC exam, because it's not straightforward. It's not like you can just go to a textbook and pull this out, right? You have to really know what you're doing, okay? All right, so let's grab my paper and then we'll answer this. Okay, so I'm gonna write f of x, and this is equal to x ln of 1 plus x over 3, right? Okay, so this is going to equal x times, I'm going to use a bracket here, okay? And then we're going to use the series, the Maclaurin series for natural log of 1 plus x to put in the terms here, okay? So the first one is x, so that's going to be replaced with x over 3. And then minus, and it said x squared over 2, but I'm going to write it as minus 1/2 x over 3 squared. I'm going to do that with each of these, okay? Because I just think it's going to be a little bit easier if we do it that way, okay? And then plus, and then it's 1/3 times x over 3 cubed, and then minus 1/4 x over 3 to the 4th, and then plus dot dot dot, and then plus, and then we have negative 1 to the n plus 1 times, and I'm going to write this as 1 over n times x over 3 to the n power plus dot dot dot. Okay, so cleaning this up, this is x times, and this would be x over 3 minus 1/2, and it'd be x squared over 9, right? And then plus 1/3, I should put times right there, 1/3 times x cubed over 27 minus 1/4 times x to the 4th over 3 to the 4th, which is 81, and then plus dot 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 plus, and then we'd have negative 1 raised to the n plus 1 power times 1 over n times, and x to the n over 3 to the n plus dot dot dot, and close my bracket, okay? Okay, so this is x times, and this would be x over 3 minus x squared over 18 minus, no, sorry, plus x cubed over 81, and then minus x to the 4th over 4 times 81, that'd be 244. No, I'm sorry. Whoa. No, that'd be 324 plus dot 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 plus negative 1 to the n plus 1 times, and this would be x to the n over n times 3 to the n plus dot dot dot. Close my bracket. Okay, so now I need to bring the x in, right? Okay, so this becomes x squared over 3 minus x cubed over 18 plus x to the 4th over 81 minus x to the 5th over 324 plus dot 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 plus negative 1 to the n plus 1, and I'm multiplying this by x, so that'd be x to the n plus 1 over, you could actually extend that fraction bar, n times 3 to the n plus dot, dot, dot. Now you need the plus dot, dot, dot here, and you also need it at the end because it's f of x if you go forever, right? The infinity part of it, okay? All right, so this is the general term, okay? And this is the first 4 non-zero terms. So we're done. That's part A, okay? Okay, so we need to determine the interval of convergence of the Maclaurin series for f and then show the work that leads to your answer. Okay, this is going to be a lot of work, okay? So you have to show that the ratio test, okay? That's what's going to give it to us, okay? This isn't a geometric series because we're dividing by n, okay? If it was x to the n, we might be looking at it like a geometric series, okay? And then we could get the radius of convergence that way, but it's not, okay? Because we're dividing by n. All right, so we're going to need to use the ratio test, and then we'll work that out, okay? So we need to find the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. Okay, so that's the limit as n goes to infinity of, and it's going to be the a sub n plus 1, right? So that's the general term, and n plus 1. So this becomes a negative 1 to the n plus 2 power, okay? And then x to the n, it was x to the n plus 1, so this is going to be x to the n plus 2 power over, and that would be n plus 1 times 3 to the n plus 1. So then we're going to multiply that by the reciprocal of the a sub n term, right? So it's going to be n times 3 to the n over negative 1 to the n plus 1 x to the n plus 1. Okay, it's just hard because you have a complex fraction. If we just go to this, it's going to make it a lot easier, okay? So this is going to be the limit as n goes to infinity of the absolute value of, and I'm going to put my negative 1 to the n plus 2 over negative 1 to the n plus 1. And you've seen me, I don't always write the negative 1, okay? You don't have to, because what's going to happen is this is going to become positive because of the absolute value. So you don't see me always writing it because it's just, this is just going to become 1, okay? And so this would be negative 1 to the n plus 1 times n over n plus 1. I'm just grouping stuff that helps me to cancel stuff, okay? X to the n plus 2 over x to the n plus 1. And then times we have 3 to the n over 3 to the n plus 1. Okay, so this is going to be just negative 1, right? And when we take the opposite value, it's going to be positive, right? Positive 1. So, okay, so negative 1 times, okay, we can't do anything with this one. But when we take the limit as n goes to infinity, it'll take care of this, okay? Over n plus 1 times, this would be x to the first power, because we're going to subtract this from this. So subtracting n will give us 0 in, and 2 minus 1 would give us 1. So this just be x to the first, which is x. And then times, and then we're going to take this and subtract. So this would be 3 to the negative 1, or 1/3. Okay, so the absolute value of this is just going to be 1. Okay, so that's going to be 1 times, when as n goes to infinity of this, it's just going to be 1. So times 1. And then this we could write as x over 3. So it'd just be times the absolute value of x over 3. So this becomes the absolute value of x over 3, right? Okay, now when does this converge? Absolutely, it converges absolutely when you do the ratio test and this comes out to be less than 1. So what we have is x over, the absolute value of x over 3 is less than 1, right? Okay, so now then, What does this mean? Okay, so my radius of convergence is well, it's not 1 here, okay? This means this absolute value of x over 3 is less than 1 has to be between -1 and 1. So -1 is less than x over 3, which is less than 1, okay? There's been a vertical stretch by a factor of 3 here, so that's why we couldn't just go, oh, that's the radius right there, okay? Because you heard me hesitate right there, because I started to say that this is the radius and it's not, because there's been a shrinkage here by the 3, or not shrinkage, it's actually a stretch, right? So we're going to multiply the left, the middle, and the right by 3, and then we get -3 less than x less than 3. And now we can see the diameter. Okay, nobody calls it the diameter, but the diameter is 6, so that means the radius is 3, okay? You can tell that this is the radius when this is just x, or like x minus something, okay? All right. Okay, so the interval of convergence is -3 to 3, but we have endpoints, right? So is it convergent at -3, and is it convergent at 3? So we got to test those endpoints, right? So we got to check at x equals -3, and we got to check at x equals 3. Okay, so that's what I'm going to do next. Okay, so when x equals -3, remember our series was sigma n equals 1 to infinity of -1 to the n plus 1, x to the n plus 1 over n times 3 to the n, right? Okay, so when x is -3, that's going to go right here where my x is, okay? So sigma, we're going to clean this up, n equals 1 to infinity of -1 to the n plus 1, -3 to the n plus 1 over n times 3 to the n. Okay, so this is sigma n equals 1 to infinity. This is still -1 to the n plus 1. Okay, and then times. Now I'm gonna look at it like this. This is -1 times 3, so that'd be -1 to the n plus 1 times 3 to the n plus 1. Okay, that's how I'm gonna look at it. Over n times 3 to the n. Okay, so I need to add these. So this is going to be 2n plus 2, right? Which is going to make this become a -1 to an even power, right? Because 2n plus 2 is always going to be even, okay? So this is going to become sigma n equals 1 to infinity of 3 to the n plus 1 over n times 3 to the n. We can even clean it up even more. And this is sigma n equals 1 to infinity. And this becomes n plus 1 minus n, right? So that's going to be 3 over n. And that can be rewritten as 3 times sigma n equals 1 to infinity of 1 over n. That's the harmonic series, and it diverges, right? So this is gonna diverge, okay? All right, so and n equals 1 to infinity of 1 over n is the harmonic series which diverges. Okay, and I realize I'm running out of space to show you this. Let me slide this up a little bit. Okay, so we know this diverges, okay, because the harmonic series diverges. Therefore, this 3 times the square root, not square root, sigma n equals 1 to infinity of 1 over n diverges. Okay, so we're not going to include -3 in our interval of convergence. So we still need to check 3, right? Okay, so I'm going to go to my other paper and I'm going to do that one. So x equals 3. Okay, so x equals 3. I wish I was doing this in front of you guys. Okay, at x equals 3, the series becomes n equals 1 to infinity of negative 1 to the n plus 1 times 3 to the n plus 1 over n times 3 to the n equals 1 to infinity. This would be negative 1 to the n plus 1. And I'm going to write this as 3 to the n times 3 to the first. Okay, so 3 to the n times 3 to the first, which would just be 3, right? Over n times 3 to the n. So my 3 to the n here and my 3 to the n here cancels, okay? And so I'm left with sigma n equals 1 to infinity of negative 1 to the n plus 1 times 3 over n. This 3 can be pulled out, so this is equivalent to 3 times sigma n equals 1 to infinity of negative 1 to the n plus 1 over n. And what do we know about this series? Even though we're multiplying by 3, we know this series is the alternating harmonic series, which does converge, right? So then we would need to write n equals 1 to infinity, negative 1 to the n plus 1 over n is the alternating harmonic series, which converges. Therefore, 3 sigma n equals 1 to infinity of negative 1 to the n plus 1 over n converges. Okay? And because it converges, we know now the interval of convergence for the series sigma n equals 1 to infinity of negative 1 to the n plus 1 x to the n plus 1 over n times 3 to the n is negative 3 less than or equal to x. Whoa. Sorry. We don't want to include negative 3, right? We want to include 3. Negative 3 less than x less than or equal to 3. Okay, and that's the interval of convergence. You could also write it like this. You could write it with interval notation, negative 3 comma 3 with a bracket. Okay, that would also be the interval of convergence. Okay, and both would be correct. Okay, all right. So let's go to part C. Okay, so let p sub 4 of x be the fourth degree Taylor polynomial of f about x equals 0. Use the alternating series error bound to find an upper bound for p sub 4 of 2 minus f of 2, okay? So this would be putting 2 in, right? Okay, so let's go ahead, and what we can do, because it's an alternating series, right, is that we can go to the next term that we have, and putting 2 in for x, we know it's going to have to be less than or equal to that, okay? So let's go ahead and go to that on our paper. I started to write this without recording it, okay? So p sub 4 of 2 minus f of 2 has to be less than or equal to the absolute value of, okay, and it would be the next term, okay? And the next term, if you look at our original problem, I'm going to that, okay? It would be this one right here, okay, the fifth one, right? by putting 2 in here for x, okay? So it would be less than or equal to negative 2 to the 5th over 324. Now, why am I picking this one? Because this is the 4th degree, right? And so if this is the 4th degree, this would have to be the next term, okay? So you just go, you look at this one and go the next one over, okay? Okay, absolute value of that. Okay, so this would be this p sub 4 of 2 minus f of 2, and we're just gonna clean this up. Would have to be less than or equal to, okay, so the negative one, the absolute value is gonna take care of that. This is gonna be 32 over 324. And you're fine with that if you leave it like that. This actually reduces a little bit. You know, it definitely goes in, you know, I'm going to work it out. If you left it like that, you'd be fine, okay? Because you have a numeric, that is the upper bound. It's just not simplified, okay? And so I know both these are even, right? So this would have to be 16 over 162. And then I notice they're still even, right? Because I don't have a you wouldn't, well, you're going to have a calculator on the AP exam, okay? Because you can use a calculator on the entire test this year, okay? So this would be 8 over 81. And that's as far as you could go with the simplification, okay? So this error has to be less than or equal to 8 over 81, okay? And that's it, guys, okay? All right, so that's part C. Hopefully, you know, this is the last day of interpreting graph problems and also the infinite series. It will come back again, but we're not going to spend dedicated time to just these over an extended period of time, okay? So hopefully you're like, I'm catching on to this, I'm getting better. And that's the whole point of this is doing a lot of these. So you just start getting better and you build your confidence and you go into the test and you go like, I can do this, okay? All right, guys, so we'll finish there and just hang in there and just be disciplined and be tough and just keep practicing, okay? All right, guys, you take care. Bye.